Let's begin with permanent magnets. Permanent magnets are substances that can retain its ferromagnetic property for a long period of time at room temperature. Let's discuss the properties of a material used for making a permanent magnet. We cannot make permanent magnets from all types of materials. The hysteresis curve helps us to select a suitable material for it. The material should have high retentivity in order to retain its magnetization for a long period of time and increase the strength of the magnet. The material should have high coercivity so that it does not lose the magnetic property during temperature fluctuations. Unwanted or scattered magnetic fields and minor mechanical damage. Also, the material should have a high relative magnetic permeability so that it can be easily magnetized. Thus, taking into consideration of all the properties, steel is the most suitable choice. The other suitable materials are alnico, cobalt steel, and taconel. There are different methods of making permanent magnets. In method 1, we can prepare a permanent magnet by holding a steel rod in the north-south direction and hammering it repeatedly. This is an age-old method of magnetization. In method 2, hold the steel rod and rub it with one end of a bar magnet repeatedly in a particular direction. Thus, a permanent magnet is formed. This method of magnetization is known as single-touch method. However, the most efficient method of making a permanent magnet is to place a suitable magnetic material in the core of a solenoid and pass direct current through it. Thus, the magnetic field due to the current-carrying solenoid magnetizes the material placed in the core of the solenoid. This method of magnetization is known as electrical method. Permanent magnets have many applications, such as in magnetic door stoppers and magnetic screwdrivers. Now let's discuss the making of electromagnets. The materials used in electromagnets should have high magnetic relative permeability and low retentivity. However, the hysteresis loop for this type of material is narrow. Considering all these properties, soft iron is the most suitable material for making electromagnets. Place a soft iron rod in the core of a solenoid and pass current through it. The magnetism of the solenoid increases by many times due to the soft iron rod in the core of the solenoid. When the current through the solenoid is switched off, the magnetism due to the solenoid is also switched off because of low retentivity of soft iron. Thus, the electromagnets are referred to as temporary magnets. Electromagnets have their usage in many applications, such as electric bell, loudspeakers, and telephone diaphragms. Huge electromagnets are used in cranes to lift bulk quantities of iron, steel, and machinery.